Robot Revolution. This intense top-down stealth shooter is one of the most popular games in the world, if you define the world as my game design class. But how was this fantastic game made? Which one of the muses gave divine wisdom to these developers? And when will this pretentious narration end? All will be answered right now. So how is it done? Simply, it's math. No, it isn't that scary. And I'll make sure to walk you through my process step by step. Typically when I code, I just jump right to the solution. But using math as a tool, I can actually find the solution before I even write a single line of code. And I'll show you that's useful with an example from my own game, Robot Revolution. When playing Robot Revolution, as you get closer to the enemies, they get louder so that the player knows how far away an enemy is. The first step to implementing this solution is to first make a model. So let's define our world as this box. And we have a listener and an audio source. They have an X and Y coordinate, and they have some distance between them. And in addition to these objects, we also have a volume variable, which is a floating point number, which has a domain of 0 to 1 inclusive, meaning that it can be any value between 0 and 1, including 0 and 1. The next step is to redefine the problem with what we already have. Our problem can simply be defined as the distance increases, we want the volume to decrease, and vice versa. When the distance decreases, the volume will increase. The next step is to simply solve the problem. We could say that volume equals distance, but that would be incorrect. If we remember what we're asking for, we want distance decreases, the volume increases. But right now, as the distance decreases, the volume decreases. What we want is an inverse relationship. I did this by having 1 be subtracted by the distance. If we put our distances on a number line, we can see that if we have a listener and a source with a distance of 0.6, we have the 0.4 remainder. And that remainder can just be repurposed as a volume value. The next step is to test our solutions. So, for instance, if we have a distance of 0, we will have a volume of 1, a distance of 0.5, a volume of 0.5. A distance of 1, we have a volume of 0. And if we have a distance of 2, we will have a volume of -1. But since -1 is less than 0, it will be limited to 0. Wait a second. If the distance is greater than 1, then the volume will always be 0. And that's a problem, because we could have a situation where the player is maybe perhaps 10 units away, and they won't be able to hear a single thing until the enemy is right on them. If we go back to our model, we can draw this 1 distance as a radius around the source. So now we need to generalize our solution that it works for all cases. If we go back to our number line, we can take these distances and instead label them as percentages, as a percentage of how close you are and a percentage of volume. Now, we can take this percentage and find the percentage for any distance with any radius. If we just take the percentage value as the distance divided by the radius, which gives us our final solution of the volume equaling 1 minus the distance divided by the radius. Once we have this final solution, we can finally code it in our game. Here is what my code looks like, and here's the formula below, and you can see how each part lines up. And looking at footage of our game with the gizmos on, you can see a green circle which represents the radius of audio. And as the player gets closer, the audio gets louder. And as they get farther away, it turns 0 when it crosses the radius. So what's the big idea? Let's review. First, we make a model. Then we redefine the problem within the model. Then we solve this problem. But that's not the final step. We need to test this specific solution, looking for issues where this case is missing solutions. Then we're going to generalize this solution for all cases so that it works no matter what. Then finally, we code it in our game. The reason why I want to show you that math is important is because I don't want you to be scared of math. It's a tool. And if you don't use all your tools, you're trying to put a square peg in a round hole. So just use math and don't be scared. I wish you luck on your game development adventures, and I hope you enjoy my presentation. Thank you for watching.